2, in case we got anybody logging in a little bit late. All right, Vid, can you still hear me okay?
Okay, everything is good. You're good to go.
All right, well, let's go ahead and get started. My name is Eric Evans, and I'm with Surveyors Source. We are a 3D survey reseller. With me in the webinar, we've got Vid Peterman from 3Dsurvey, and also Derek from Surveyors Source, excuse me, should also be in with us here shortly. We'll get started just with a quick introduction. I've been in the surveying and mapping industry for about 20 years in various support, sales, and training roles. My first experiences with this type of technology was came out about 2007 when I first started using laser scanners and started manipulating with point clouds. Now we're not, this is photogrammetry and not laser scanning, but the end product is still point clouds, and how we use them and how we deal with them is very important. About 5 or 6 years ago, started getting involved with UAVs back when we needed a licensed pilot to be able to fly UAVs for us. Thankfully, over the past couple of years, those regulations have been relaxed, and I am a licensed UAS commercial operator. But for the past 2 years, I've been using 3Dsurvey. I have experience with some of the other photogrammetry softwares that are out there, and as we go along during the presentation, I'll highlight things that I think that 3Dsurvey has an advantage of, and things I think 3Dsurvey does extremely well. Let's get into it. I've got a short PowerPoint. Now for these type of presentations, I'm not going to overly PowerPoint things. I like to get into the software, show the operation of the programs, and actually use and manipulate some data. We'll start with a basic introduction to photogrammetry. For those who are not familiar, 3Dsurvey is a photogrammetry processing software at its core. 3Dsurvey's workflow, which is really easy. And if there is a barrier that I've heard from people trying to get into the technology, it's how do I use it? How easy is it? 3Dsurvey is an extremely easy workflow. It's very powerful, but it is easy to get into and easy to start with. I'd like to get the data from 3Dsurvey and import it into CAD. In this case, I'm going to be using Carlson survey. I think the UAS processing, getting all the data, getting that together is great, but what do we do with it? And that's the point of this webinar. How do we take that data and actually use it for things that we normally would be using for our day-to-day business? And that's what I want to highlight here with this webinar. So we'll bring the data into CAD. Now, fair warning, I am not an expert CAD operator. I can use the software for certain purposes, and that's about my extent of my my expertise on that particular area. But we'll be able to show the data into, in this case, Carlson software for CAD, and be able to actually produce data that you would normally use and see. The process here, I know it's not going to take the full length of the webinar, so there'll be plenty of time for questions and answers. As a bonus, after we've gotten through the presentation, at some point here, I will show a project that we did with the brand new DJI Matrice M300 RTK with the P1 camera. And if you've been keeping your eye on that particular product, I've got some data that I'd like to show that I think is very powerful. And that new device and new camera, I think is really exciting. And there's some future developments there that we will definitely highlight as we go along. But I've got a small sample project, and I'd like to show that to you guys just to give you an idea of what it can do. For those not familiar, this is photogrammetry. It gets confused sometimes just because the data we are producing is point cloud, that it's laser scanning, and it's not. It's using photos to create three-dimensional data. How we do that is we set up our UAV to fly a pattern with a certain amount of overlap. And the 3D survey software is able to take these photos and calculate three-dimensional points from the pixels on the photos. And it is pretty amazing technology. I'm not an expert in probably in explaining how it works, but it is a technology here that I think has matured. And it's not, to me, the cutting edge anymore. It's the now. It's what we can do now. And it's not far-reaching. It's something that everybody, I think, has access to. The true advantage, one of the true advantages, I think, with this technology is the ability to cover very large areas in a short period of time. I've got a little project I want to show you. It's not very big, but it's something we flew in just a couple minutes, and with maybe an hour or two of processing time, we were able to come up with a finished data set. Whereas with traditional survey means that might have taken a day, depending on the level of detail that you wanted to capture on this particular area to do in a traditional method. When you start expanding that up and doing very large areas, then the advantage becomes that much greater. An example, the biggest project I've worked on was 15,000 acres, and we did a 1 foot topo using the drone. We flew it over a couple days, took a couple days to process, but 15,000 acres to do that traditionally, especially in this remote area where it was, would have taken probably a week or two. And we were able to do it in just a couple days. So the time savings are extreme, but also the level of detail you can capture. And we'll look at the data set here, and you can see all the details that are captured using the drone. It's just a huge advantage of doing it that way. All right. Again, I'm not going to overly do it with PowerPoint here. So we'll skip from this section here and go right into 3D survey. I wanted to put this up here because this is what my computer specifications are, and it's not terribly impressive, but it's a good computer. I just wanted to show this to highlight you don't need a supercomputer to run the software. Although the more memory, the larger the hard drive, the better the processor, the faster all the processes go. And this is my setup, and if anybody wants to petition my boss for a little bit more memory, I'd appreciate that. But it's certainly a very reachable computer, I think, for most users out there. All right, let me see if I can skip over here to 3D survey. All right, Vid, can you see 3D survey now?
Yeah, we can. Yeah, we can see.
Okay, perfect. All right, so this is the first screen that comes up when you open up 3D survey. Again, the workflow in 3D survey, I think, is really easy to learn. It's just a few steps. We will simulate as much of this as possible because I don't want to waste your time with loading screens coming across. So we'll start by starting a new project. And with 3D survey, all we need to do is find the photos. In this case, it's not too many. This project only has about 55 photos, very simple. And I'm going to highlight all the photos I want to use and hit open. And in a few seconds, we come up with an importer screen. Now, really all I need to know is this data came from a DJI product, so it's got the location metadata behind it. This is a known projection. In this case, my neck of the woods would be New Mexico State Plain. I have a geoid applied, although I don't have to do that. And very simply, we'll get the data into 3D survey. I'll get a little report. Now this was done with a Phantom 4. It was not using RTK, but I've got enough ground control here where I still ended up with a very precise product. Now this is the telemetry view that we get when we import the photos into 3D survey. Again, it's a very small area. It's a park here, a little north of me. That's also a AMA field, so it's a field that I like to practice at, where drone flights happen on a fairly regular basis. It's well outside of any airspace, so it's a nice little area to fly. It's also used for some sort of soccer field, I think, is also here, but obviously I didn't fly it when they were doing any of that. So we're looking at an overview here. Each of these icons indicates that's where a photo was taken. I can also switch to what's called a, no, I'm sorry, I'm gonna go back to images. So this is the first step, and all I'm doing here is, looking at the area, make sure it's where I think it's at, and then I can jump in and start with the processing. Now, the first step, these are basically the 3 steps that you take here If you can see my cursor on the bottom right. First step is a bundle adjustment. And this is kind of our starter adjusting, bringing in, starting to produce data from these photos. Now I'm not gonna hit the bundle adjustment here. I'll skip to the next step. It took about 20 or 30 minutes to do the bundle adjustment for this many photos. So it's usually a pretty fast, quick step. So I'm going through the magic of television here. I'm gonna jump to sort of the next level of processing that I've done here. I'll not save that because I don't need it. All right. So from the bundle adjustment, first thing we get is what's called the sparse point cloud. Now you can see that the triangles here, or the pyramids, are the direction and orientation of the photos we took. So it's showing you where the photos were. And we end up with this sparse point cloud, which is just a non-densified kind of basic point cloud. So as we zoom in, you can see that these are just three-dimensional points in space. And that's really what the software is doing, is taking these photos and producing these three-dimensional points. The next step is to densify the point cloud. In this case, and pretty much in most cases, I think, we're going to use ground control points to do so. So if we follow along here on the bottom right with our steps, orientate is the next step. And in this case, I'm going to say with GCP, which stands for ground control points. Now I've already got the GCPs loaded. All I need to do to load the GCPs is to select a common delineated text file, which I just produced from a GPS. Now I'm going to back up one step here so I can show that this is a fairly small area and I've got 4 control points. And I often get asked, how many control points do I need for a particular project? In this case, this small of an area, 4 control points, that's probably too many. But I've always tend to over control the flights that I do, just to make sure I've got plenty of control. Now, is there a good rule of thumb? I think it kind of depends on who you ask. I like to treat setting my GCPs kind of like I would a localization. If you guys are, if anybody's familiar with RTK GPS out there, treat it kind of like a localization. For this small of an area, I could probably have set 1 GCP and probably been good. That probably would have been fine. As I go to larger areas, I typically will set the GCPs kind of in the corners of the project, kind of box in the area that I want to capture. If I start doing very large areas, maybe I'll add a couple control points toward the middle or a couple more on the edges, kind of to, again, box in the area that I'm going to be flying. With an RTK drone, from talking with others who use the technology and are proficient with using them in the field, 3 control points per flight or per battery might be a good rule of thumb to think about. But again, I tend to over control with my GCPs just to make sure I've got plenty of coverage there. All right. Oh, that's not what I wanted to do. Oh, that's the telemetry one. Okay, sorry. Import, orientate with GCPs. I've already got them defined here. And simply what I do at the next step is I find the GCPs in the photos. In this case, I'm using 3Dsurvey's targets. These targets are specifically designed for the software. They're about a 1 foot square target with a large black dot in the center. Simply right-clicking on it in 3Dsurvey is all I need to do. So really just going and physically finding the GCPs in the photos is really all that's involved in this step. Now, once I go through and I start clicking on at least 3 of the GCPs, and in this case, obviously I've already done it, the 3Dsurvey software is smart enough to, once I locate 3 of them, to get the approximate location of the rest of them. And then I get a little report here that says estimated GCP error, just to make sure I haven't clicked on the wrong GCP. Now, a quick field tip would be, if I was doing a large project with lots of GCPs, I'd take some upside down spray paint or inverted spray paint and put the GCP number next to the target, just so I can confirm to myself that I know what GCP that is. It's a really easy way to go through, and you can see, if you put it large enough from the photo, what GCP you're actually recording. But the software, through the 3Dsurvey software, is smart enough that if I choose 3 points, it will automatically go in and put the other, or locate the other GCPs for me. Now, if I hit next, the next step would be to verify that the GCPs have been located correctly. In this case, since I'm using the 3Dsurvey targets, it automatically identifies the middle of the target for me. If I used just a paint mark or maybe some lath putting across as my GCP, then I might need to go in and adjust these and make sure that the actual center of the target is identified. You can see some of these are in red, either because the angle was bad and it couldn't identify it. Generally, I'll leave those alone because I'll trust the software if that's a good GCP location or not. This step is just kind of verifying that I found my targets and that I've accurately located the center of them. Now at this point, I think I can hit next without messing too much up here. All right, and then I get another kind of estimated error. This takes just a few seconds, depending on how many GCPs I've done. Now, if I have any targets that show high error, I can always not include them. Some examples I've had of when that's come up. I had a project at a landfill where I put down a target and a tractor ran over it. So obviously I couldn't use that anymore and it disturbed its location. But for the most part, this is just a verification step to show that I have indeed located the targets correctly and that I've got a good orientation. Finish that up. All right, at this point, I could run what's called a reconstruction. Now, reconstruction is the step where with the software, we'll use the GCPs and densify the point cloud. Now, that step takes the longest out of the steps that we've done. But you can see I've just followed along here in order these 3 steps to start processing the data. And that's pretty much this is the beginning steps to actually start producing data. So you can see it's not anything terribly complicated. I'm just following along here with the steps and it's producing data. Now, compared to other software I've used, this is a very, very, very easy to follow workflow. Incidentally, 3Dsurvey has a lot of good materials on their website for showing these steps. If you need to go back and refer to them, or if you haven't used the software in a while, or you want to learn it, it's good stuff and it's free on their website. So I definitely recommend checking that out. When I reconstruct, I have the option to say what level I want to reconstruct. It's kind of a low, medium, high, and higher. I think this particular project I did was processed on high, if I'm not mistaken. Now this process again would take, I think this one took a little over an hour with the machine that I'm using to process, so I won't make you guys go through that. In this case, we'll jump ahead and we'll look at the point cloud. Now this is the densified point cloud. After I've done the reconstruction, this is what I'm getting. It shows me here that's 25 million points out of this area. If I zoom in on it, it looks like a picture. It really does look like I made a surface and attached a photo to it. If I zoom in, you can see what it really is just a mass of 3-dimensional points. So just a bunch of points all densified together for this area. Give you an idea of the level of detail here. So this was a park, basically, that's also an AMA field. And there's a lot of people running and walking their dogs. And I found when I was walking around doing my GCP that there was a hole that a dog had obviously dug somewhere near this bench. And I was curious to see if I could see it. If I can find it somewhere around here. You could actually see where that dog had dug out a little hole over here. And that's the sort of level of detail that we're getting with this software. I'm pretty impressed. Obviously, that's more detail than I would likely need to define this area, but that's the sort of levels of detail that we can get with this program, or with photogrammetry in general, I should say. And again, this is just done with the Phantom 4, and I wasn't using the RTK in this particular case because I had a lot of ground control to use, but certainly enough to do the job. All right, so we've got a really nice looking picture here, but now what do we do with it? Now, this is all 3-dimensional data. I can make measurements on this just like I can with any 3-dimensional point, but I want to do a little bit more with it. I want to take this a step further. In this case, I'm going to do what's called classification. Now, I want to stop here and highlight something. Over the years, I have literally sold software for 2 to 3 times the price of 3Dsurvey to do this one step. So when I first started using this program, this was something that jumped out at me as being an incredible feature of the software. the ability to go in and clean up this data in an automatic way and not having to spend a ton of time doing it, I was very impressed with how this software did this particular thing. So here on my tool set under point cloud, I've got something called classify. We'll jump into that. Classify is going to do is basically just get me the points that are on the surface. So things that we don't want in our topographic maps, the benches, trees, brushes. There's a staircase here with the handrail on it. I don't want that. There's kind of this earthen dam area with this little kind of large sign here. I don't want that in my topographic map. There's kind of this little spillway structure over here. I really don't need that to show up on the topographic map either. So this step is crucial for creating a data that I can actually use and start working with in a CAD environment. The defaults here are always set up for you, so I typically don't mess with that. Now it's asking me, it says select some of the biggest terrain regions in the point cloud. So basically I need to tell the software where the ground is. In this case, it's really easy because it's right there in the middle. And I'm just going to click on it. What the software then does is looks across the point cloud and starts looking for features that don't look like they're on the ground. Now, again, this is something I want to stress is I find this to be an incredibly useful feature. Now, my machine's slowing down here a little bit, but if I can take the point cloud and move it up a little bit, I can show you what I mean here. A lot of these features, again, that I don't want, this little spillway structure over here, there's a little sign feature over here that I really don't want. They're not in red. So things that are not in red, the red's going to be the ground. So that's what's giving us ground. So those things I don't want, and you can see that they're not highlighted, and I'll see why that's important here. I'll show you why that's important here in just a second. I'll hit next. Now, if there are areas that the software did not get, say something was separated, a lot of times it'll be something that's beyond a fence, or say you're doing an area that's got houses, something in another yard or another area. Sometimes the software doesn't necessarily pick up on those things. And we can actually manually go through and select those different areas if the software did not pick up on it. In this case, this is fine. Everything I want is on here. I'm gonna hit finish. All right, I'm going to do one step that I forgot to do earlier is I'm going to duplicate this point cloud so I have an original copy to go back to. I always do that in case I do something and I want to go back or have the original data available. I like to have a copy of it just so I can have the original to always go back to. All right, so I've got my ground points highlighted, and all I'm going to do is hit delete other. Anything that wasn't highlighted by the classification is now gone. So you can see that spillway tower is gone. That little kind of sign area here was removed. And now I've got a point cloud, excuse me, that I can reliably know that these are just ground points, that this is just stuff that's going to be on the ground. Again, I have in my career sold software to just do that one step, and I think that's an incredibly powerful function of this program. All right, I'm gonna do something else here to kind of clean this up. You can see that some of these kind of outlying areas, you end up with data that is not quite complete. That's because as a drone flies around, there's data that we don't have pictures of, or don't have a lot of pictures of, and that's normal with drone surveying. In the field, what I'm gonna wanna do is make sure that I get a buffer around the area I want to fly so that the area that I want to focus on is well covered. And in this case, I was just focusing on the field, so this is fine. I'm going to run the selection tool here real quick. I'm going to go and just box around the area that I really care about. And all I'm doing is just drawing a box to select what I want. And here in a second, it'll highlight it. And then I'm going to delete anything that's not in that box. So again, I've just got a data set that focuses on the data that I really care about. My computer will behave for me here. We'll say delete other. And there we go. I just have the point cloud for the area that I want to focus on. All right, so I've cleaned out anything that was in the way. Now I want to create a surface out of this. And then in the case the software calls it a mesh. I can look at my mesh pull down. I've got a couple different meshes. Now this 3D mesh seems to be more related to doing things like buildings or things that I want to model. But for our regular mapping and surveying, we want to create a digital surface model, or DSM. Now this, if you use CAD, should be a term that you're familiar with. Again, I'm going to accept the defaults because they're well set up. And we'll calculate this out. Now let's take about a minute, and it depends on the area that you have. But this is the step where now, instead of looking at points, now I've got a actual stitched together surface. Now I'll stop here and mention something. 3Dsurvey has a contouring routine in it, and it's very good. But for, I think, many CAD users out there who regularly use CAD, they've got standards set up for creating their maps and mapping that they would likely want to keep. So I think the purpose that I wanted to do for getting to this step was, now we can stop, and I'm actually going to create data that I can bring into a CAD environment. How I do that is under Mesh, I've got the option to save as. Now, I am going to create what's called the LandXML file, but you can see there's plenty of other formats. LandXML, I remember a couple years ago that this was kind of a new big thing that was coming out. And LandXML is an offshoot of HTML. It's a universal format. It's accepted by just about every CAD and mapping application that I'm aware of. And I think it's really powerful. Now, I'm not sure if it's as well used as I think maybe it should be, but I think it certainly has a lot of value. So when I do this, I'm just going to overwrite one of these that I already created, and we'll just replace it, and that's it. Now I've created a XML file for this surface that is data. If I went out with a GPS and took a bunch of points on this area and I created a surface out of it, it'd be the same thing as what I'm doing. Now, obviously, this is more dense. There's more to this, but the result is the same. I end up with a CAD surface. So really what we're doing is just using a different method to create data that you would already be using, that you would already be working with. And so it's going to show me that file here. Now, again, I can go in through 3Dsurvey, and there's a contouring option here. But in this case, I'm going to now skip over to Carlson and use their software to kind of finish and create my maps. Now, I am not a super proficient CAD user. I can use the software for what I need to get out of it. If there are more detailed questions that you guys might have, put them in the chat, and I'll see how many of them I can answer. But what I'm going to do is something that's very simple, and what I want to highlight here is even I can do this. If somebody's not proficient with CAD, it's something that even I can do. So in Carlson here, we can create a new drawing, and it runs me through a wizard. Now I'm just going to use their standard template. Now you could go further than what I'm going to do, actually creating a paper space and doing all that sort of stuff. But really, I just want to get through and start mapping. First thing it asks me to do is set a drawing name. I'm just going to overwrite one I did before. The scale, this is not a very big area, and I'm just going to put it at 15 scale, which should be fine. I am going to set up a projection here so I can mess with that a little bit later. And again, I'm going to match the projection that I did with the project data. And everything there looks good. All right, I'm not going to start with a coordinate file because I don't have any points existing. I'm not going to import any data because we're going to do that from LandXML, and that's pretty much going to be it. Now, before I get started, I do need to change my units because I had the project set up in international feet, and I want to make sure that I match that here so I don't have any issues. Okay, so now we've got a blank drawing. What I can do in Carlson is import from XML. There it is, LandXML file. I'll go and find that surface that I created. In this case, I put it in a folder that I've already got kind of mapped to. I'm going to hit open. Now it jumps up with a dialog, and it's basically reading the data from the LandXML file. Again, LandXML is a standard format. There's actually a LandXML consortium that gets together and defines these standards. So any CAD or mapping program that deals with surfaces should be able to read a LandXML file without a problem. All right, and identified my surface. I'm gonna leave the defaults on and we'll hit import. Now, it's just importing this surface file and now it's available in the drawing. There are a couple different things I could do to manipulate this. I'm gonna go through the simplest step and just start drawing contours. And there's obviously more that you can do here. Something that'll jump out is break lines. Now, if anybody has an opinion on this in the chat, I'd love to hear from you. With the density that we get with UAV mapping, are break lines still required? I've heard that out there. I'm not sure if that's true or not. I'd like to hear an opinion for anybody who has one on it. Now I can define break lines later in the software. Carlson allows me to define break lines by polyline. So I could have either gone out with a GPS and let's say the staircase is something I didn't want to have contours shown in, or maybe there was a building in the center there that I didn't want to have contours going through. I can go out and record points on that, make that a polyline, and have the software identify that as a break line and then not contour in there. So there's a couple different ways to handle doing break lines, but I'd be interested in the chat if anybody thinks that they're still required given the density we have with UAV mapping. All right, we'll let this process finish here. Yeah, let's take just a minute. So after this is done, again, this the software is reading the LandXML file and reading this standard format and pulling things that I would need into the drawing. Now, this is obviously very detailed. I didn't do any cleanup here. What I could do is at this point is stop, go into the surface manager, simplify the surface if I didn't need all this detail. That would make the drawing smaller and a lot easier to deal with. In this case, it's such a fairly small area that I'm just going to go with it as is and not do any simplification on it. Now, again, I'm just dealing with data in a CAD environment. This data could have come from more traditional means, but what we're dealing with here is just a surface. It's just data at this point. The fact that it was done with the UAS is now kind of taken out of the equation, and it's data that I would normally be dealing with regardless of whether it came from a UAV or not. Now, this is taking a little bit longer than it normally does. My computer might be slowing down a little bit here because I'm also hosting the webinar up here, but we'll just give this a second to finish processing. I think I timed this at a little over a minute when I was doing my practice run through. Now, any questions out there so far? I haven't seen anything come up in the chat, but feel free to type in any questions that you might have or anything you want me to potentially show in more detail. I'm gonna go back to 3Dsurvey because there's one step that I want to do that I had forgotten about, but I'll wait for this to process. And the step that I was thinking of doing was creating the ortho image, which I want to use as a background here eventually when all the data gets imported correctly. There we go. So next dialog will come up. Will let me do a few more controls. There you notice there will be an edit button that will have some controls for doing things like break lines. In this case, I don't have any, so I'm not going to worry about it. But I'm just going to go through the regular contouring dialog box and select my normal standards or my normal defaults. So if you use a CAD program for contouring or for mapping purposes, you can use your same set standards or the same normal defaults that you have to create contours from this data. And that's really what I wanted to highlight with this webinar is the data that we're producing is data we can use in our everyday projects. This is surface data. I can go in, contour an area, create data that I normally would create anyway, and just run off of it. So the method here becomes just a method for producing data. And for some reason, I think I've locked up my computer here. We'll give it another minute, see if it's finished this processing. While we're waiting for that, let's just jump back into 3Dsurvey, and I will show the step that I wanted to do, which is after I get the mesh, I can use 3Dsurvey to calculate a ortho photo. Now, if you're not familiar, it's the individual images stitched onto the surface. So you get actually a corrected single photo to use as, in this case, it'll be a background image in Carlson. I don't know if I want to do this because it takes a minute to calculate the photo. And this is still kind of struggling over here. Now, I might get the screen of death here in a moment. All right, I'm gonna have to go ahead and kill this and try it again. Yeah, I'll just run to the end here. All right, I'll start that again in here in a second, but while we're waiting for that, let's calculate the ortho. Again, the defaults here are well set up, so I will take a look at the size of the photo for those who are into photography. I've done some massive photos in the past, and they can get quite large depending on how much detail that you really want to set up. But certainly, everybody understands the satellite image. Google Earth is something that most everybody is familiar with using. So creating something like an ortho image is a real powerful tool. And it goes into something else that I think that UAVs can do for a business, is to add another level to your services. So instead of giving somebody just a sheet of paper with some lines on it that represents their map, we can take that a step further and actually create a background image to project our data onto. That's not just some kind of loosely put together some kind of blurry Google Earth image, but actually has substantial amounts of detail to it, as you'll see in the ortho. So again, it's taking data and just putting it up a notch, elevating a bit for creating data that we would normally do. I mean, background images have been something that we've seen in CAD for a long time, but now we're taking a level of detail that we would not have access to before, and we're kind of upping the game a bit in terms of data that we can produce for customers and clients in our normal everyday workflow. I think what I'll do is, after the ortho's finished calculating, I'll shut down 3Dsurvey so it's not taking up any memory. Now, normally Carlson's not a program that's very intense for manipulating this type of data. This is fairly dense data, again, because I haven't gone through and simplified it any. So it's a bit more detailed maybe than a standard surface, but it's nothing I haven't processed before. Now, if there's any Civil 3D users out there, Civil 3D is not a program that I have, but I do have users of 3Dsurvey who do the same sort of thing into Civil 3D. So I don't know the exact process of that, because again, I'm not a Civil 3D user, but it's something that can be done with Civil 3D in their workflow, as I do have users that do have that as part of their workflow. All right, give that a minute to finish up. And this is a nice feature to the software, I must say, is the autosave, because I am someone who does not save as often as I should. So definitely like that feature. All right, so I've got an ortho. Let's go ahead and save it out. And again, 3Dsurvey has most standard formats already built in. This is going to be a 3/4 inch resolution. We'll go with the defaults and actually create in this case, it's going to be a GeoTIFF. I think that's one of the more common formats out there. All right. Okay, let's go ahead and close 3Dsurvey and let's see if we can get Carlson up and going again. All right, we'll go quickly through the steps that we did previously. And a drawing. We'll go with the default template. In this case, I won't overwrite the old drawing. I'll just create a brand new one. Again, I'll set the scale, something that might be appropriate. Whoops. Okay. Let's give this a shot. I'll change my drawings, but international feet. Okay, that. All right, back to where we're at. I'll import the XML. Okay, let's see what we get. Usually this process doesn't take too much effort. All right, we'll give it a second here, see if it finishes up.
Eric, maybe just open the task manager and see what's happening with the processor and memory.
Let's see what's going on here.
Just press Control+Shift+S there like that.
Okay.
And if we go to processes or details.
Yeah, it's taking up a chunk, but not a killer way here. You know, the other thing I've got really open is GoToMeeting and PowerPoint. I might select another XML file instead of that one to see what's maybe that file.
It definitely is responding, just don't close it because I can see that the memory is going up and down. So that means that it's running, it's not, it's just taking a lot of time to read the file in because it has a lot of triangles in it. So just don't close it, we'll eventually manage.
Yeah, and I think maybe because I'm doing the GoToMeeting, like I say, I clocked this before with this particular area, and it took, I think it was under a minute or about a minute to import this particular XML file. Even it's fairly large, it's got a lot of triangles. It's still, imported okay last time, or when I was running through it.
Mm-hmm.
I'm not seeing any. Do you see any questions in the chat vid while we're waiting for this thing to hopefully come back to life?
Oh, no questions in the chat. So if anyone has a question at this point, you can ask it in chat and we will answer it immediately or later at the end of the webinar.
Yeah, see, it's giving this 10 fails internal check, like something, I don't know, like I wonder if something's wrong with that file that it did. Yeah, it's still using the memory up and down. There it goes. Okay, let's close this up. Sorry about that, everybody. Usually when it gets to this step of contouring the elevations, that's when I know I've got it. Now there is a way in Carlson to import the surface and simplify it so there's not so many triangles. Again, I felt this was a small enough area that I could get away with not doing it, but we'll get there. We'll get there eventually. We're getting close to time here, so I want to at least get the contours drawn, and then I will show the data from the P1 project that we did. Now, if you're not familiar, DJI released the M300 RTK, which is kind of a successor to the 200 series. We've had some experience with it, and it's a drone that we really like. Now, the Phantom 4 RTK, I think, is still the standard for most surveying and mapping applications. It's a drone that's well known. Well, what separates the M300, in my opinion, is a couple factors. One of them being the flight time is significantly increased. The batteries on that particular UAV are very large, so you get a lot of flight time from the drone. So that's a huge advantage, covering very large areas, not having to have multiple battery changes. The other thing, though, is the new P1 camera, which is a high-resolution full-frame camera with it has interchangeable lenses. What we did in this particular flight with the M300, it's one of the first ones we did. The size of the photos, the resolution of the photos is impressive on the P1, but what I think is more impressive to it is how fast it will shoot, how fast it can take pictures. Now, what that matters is we can set the speed of the drone to be much faster, but still be able to capture good, crisp data for mapping. So not only can we fly a large area, but we can fly it very quickly. So I think for doing larger projects, that's where that particular drone and that particular camera setup are going to shine. And the project that I'll show you, it was done at an elevation of about, I believe that one was about 300 feet, and we're able to set the flight speed to be 30 miles per hour. And the camera was able to keep up with that without a problem. So depending on the elevation that you fly, that's what's going to limit your speed of doing it. And in this case, we're able to fly at a moderately high elevation, but still be able to capture data very quickly. And I think that is a pretty exciting development. That I think the M300 is going to be kind of the new standard for the high-end drones. All right, let's just jump into 3D survey and I'll show that, and we'll come back to this and see if it does actually finish processing. All right, so I've got a couple of versions of that. I want to show this one. Now, when we get the images to load here, there's one particular image that I want to look at. Now, I know Derek had, when we were starting to look at this camera setup with this drone, he went out there kind of and got some, went on social media and looked at what people were saying about it, and there was some mention of the images being blurry, about the camera not performing as intended, and I've got to say we haven't noticed any of that. I'll run through a couple of pictures here and I'll show you the point cloud. I like this picture though. It looks just like a normal photo. What I really liked about it, when you zoom in to give you an idea of the level of detail, we can see that somebody was out there walking their dog, and you can even tell that's pretty sure it's a golden retriever. So the images have been really crisp, and keep in mind this was done at about 300 feet at about 30 miles per hour. So it was done very quickly, but still the crispness of the photos definitely comes through. So if you take a look at even the point cloud, which looks very similar to a point cloud that would have been done with the Phantom 4 RTK, it's the speed at which we can capture this information that I think makes this setup of this UAV particularly attractive. Let's see, it's a detailed point cloud for sure. It's accurate. We've run the numbers. This was done with ground control, so it's a very accurate survey. But I think what separates what this technology is going to be able to do is the speed and size of projects that we can work on is just going to be that much bigger and that much better. And I don't think this is going to unfortunately get there. I apologize. Again, I did this with this particular data set just to practice with it, and I didn't have a problem with it. And I think something's just either it's a file or just the fact that I'm hosting the webinar that's kind of slowing things down. No, it's not gonna let me do it at all. All right, I don't think it's gonna let me do it, Vid. I don't think I can even.
Maybe, you know what, maybe we can try making a new digital train model. Let's maybe make it at 6 or 9 foot grid cell size. Save that one into XML and it should open faster.
Okay, let's give that a quick try here. So I really want to show the contouring dialog because, like I say, it's at that point that that it's just data. Let's go here and take a look at. You should everything I want. I'll not save that. Okay. Let me see if I can just end that task. Okay, looks like it did end. Oh, there it is. Okay, let's see what we can do here. All right, so let's make this real simple. Okay. All right, so I've got a smaller area. I won't even clean it up. I'll say calculate. And this is what you wanted to change here?
Yeah, so let's change it to a grid cell size of 3 or 6 feet. We'll set it to 3 feet, so that's about 1 meter.
Okay,
I think
so we'll save out the mesh again, so we did before. And we'll say LandXML. Okay, let's see what we can do now. Okay, real quick. Jump through, set up our drawing. All right, import and call that surface 3. A lot shorter load time. Ah, there we go. I'll just didn't change my units, but I'll just go for it anyway. You can see the triangle size is significantly different.
So yeah,
There we go.
Less triangles important, a lot faster.
Right. Okay, we'll get to the part where I want to start with, where I wanted to end with. And this is the same contouring dialog that you would get, again, if the data was created from more traditional means. I'll set the contour interval to be every half foot. It automatically sets my index. Again, if I've got my standards already established for how I create my topographic data, this is the same exact dialog box that you would get. So once we have that drawn out, it's finished. There we go. All right, apologize for all of that. Again, the data was probably a little too much for trying to do the webinar and import all this into CAD, but this is a regular contour map that you'd produce from traditional data. It's just instead of doing GPS or total station, now we are using the UAV. Oh, no problem. We know the feeling. Yeah, it's always when you need it to, so something happens when you're right in the middle of a presentation. So I appreciate you guys' understanding on that. All right. I don't see any questions to the chat. If you guys would like more information or more details, I'm going to bring up the PowerPoint so I can show my phone number and email address. Thank you guys for coming. Thanks for watching. Thanks for attending. We'll do some more webinars here, try to do this on a regular basis, try to bring up some interesting topics. If there's a specific topic that you guys would like to see with the software or with producing data, please let us know. Please send me an email. Also visit our website, www.surveyorsource.com, and make requests there as well. 3Dsurvey's website is 3dsurvey.si. A lot of good materials out there. The webinars get recorded and shown there, so you can watch other webinars for other types of presentations on different things. I love their library of videos. They've got a lot of good videos for that could be like access as tutorials or training that are very well done. We also have, we'll start posting some videos on our website. We've got a video on the M300 you guys can check out that does kind of an unboxing showing the different components of it. So we'll start or continue to post those materials there as well.
And before we go, another interesting question popped up. So Carrie is asking, hey, I heard you mention that 3Dsurvey users were able to bring in a surface into Civil 3D. One of my clients demoed 3Dsurvey, but they weren't having success bringing the surface into Civil 3D due to the size or density of the point cloud. Mm-hmm. Any idea what they were doing wrong? Perhaps a setting in Civil 3D or 3Dsurvey. So I think they were having a similar problem that we were having here in Carlson. So 3Dsurvey will support a very big number of triangles, but other softwares might struggle with that amount of data. So usually it will help if we have instead more reasonable grid cell size, so maybe 3 feet or 1 meter. So this works for most the cases. Or if our area is very big, then we might use 6 feet or 2 meters for the grid cell size. So that brings the triangle count number down a lot, so it helps a lot for other programs to manage. And if you think that 1 meter or 3 feet is a lot for grid cell spacing, just compare that to traditional measurements where we usually just record 1 point per 5 meters. So it will still get a very good digital terrain model. So yeah, the main thing is Just pay attention to the detail of the surface that you're trying to bring into Civil 3D or Carlson. So this usually helps. So that was it. Back to you, Eric.
Well, I mentioned also, I think you mentioned something about point clouds as well. The creation of the surface, I think, is the best process to go through when creating data and presenting it in CAD. Some CAD programs can handle point clouds, but typically they don't handle it very well. Whereas the surface is a lot lighter data set than a point cloud would be. And so it's simpler in 3Dsurvey, which can handle a lot of point clouds and produce data very easily, to be able to make a surface simplified, as Vid said. That's why we had so much trouble with this one. Is my system wasn't able to handle the webinar and that large data set at the same time. But simplifying it down to something that would be more reasonably sized is a lot easier process than trying to deal with a point cloud directly. And that's part of what I wanted to present with the webinar was we're producing this very dense, detailed data, but we're still getting things that we can use in our normal environments. And like Vid said, simplifying the surface might go a long way if you're having trouble with a really dense, detailed surface. And I like your point there, Vid, as well. The data, if you think about how we would normally even do an area this size, which is not very big at all. We wouldn't do a point every foot to get a 1 foot contour. That wouldn't be practical or realistic. So we're capturing a lot of data, kind of paring it down to something we can use a little bit more easily, but again, still producing data in formats that are standard, that are very well known.
Great. Perfect, Eric. So thank you for this presentation and thanks to everyone for attending. Okay, I see that another question just came in. So it says, may I ask a question, maybe a little off topic, but it's about export of point cloud from 3Dsurvey. So Davor, which software you want to export the point cloud from 3Dsurvey to? Okay, Davor is using ZVCat and ActCat. So I can tell you for AutoCAD, if you want to import out the point cloud into AutoCAD, you have to save it into LAS, and then you have to import that LAS into Recap, which is a software that comes along with AutoCAD. And using that will work. ZVCat and ActCat, those two I don't know that well. I'm not sure if ZVCat supports point clouds. I can Google it real quickly.
So while Vid's doing that, I have on the screen here the different formats that 3Dsurvey will export point clouds as, and they're the standard formats that I recognize, even from laser scanning point cloud data, are supported. And this would be the export that you would need to choose or find the best one that works for your particular platform, and export them. Incidentally, something that 3Dsurvey can do that, again, I find very powerful, is its photogrammetry software, but you can also import point clouds into it. So if you have point clouds from another source that you want to use and manipulate and work with, 3Dsurvey will do that. It will import the point clouds from, again, these same sort of formats, and you can use the tools in 3Dsurvey to work on point clouds from an external source.
Yeah.
You'll see that LAS is here. Also, E57 is a format that I use a lot because it's maybe not as widely supported, but certainly is a more compact format for point clouds that I really like. It's the Surveyors Source. In addition to working with 3Dsurvey, we also work with Leica laser scanners and software. So many times I'll have data 3Dsurvey that I might want to bring into Cyclone, for example, from Leica. Some of these formats work real well. LAS, PTS, E57, they go right into those sort of point cloud applications.
Okay, so Davor, about your question, probably it will be best if we speak directly. I remember the PCG format. It used to be you can try downloading Qubit plugin for AutoCAD that will allow you to create a PCG format out of any kind of text file. And ISD, I think you can make that one with AutoCAD Revit out of LAS format. So yeah, we can hear about that one privately.
Okay.
Great. I think this was it for today's presentation. Thanks again to everyone for attending, and see you next time.
All right. Thanks, everybody.
Bye-bye.